वेलकम टू वेदादी क्लासेस। वेदादी क्लासेस में आपका स्वागत है। टुडे वी विल स्टडी द हाइड्रोकार्बन चैप्टर ऑफ क्लास 11th. दिस इज द थर्ड वीडियो ऑफ फोर्थ वीडियो ऑफ हाइड्रोकार्बन. Today we will start with the physical and chemical properties of alkene. So in our earlier video we have discussed about the preparation of alkane, chemical and physical properties of alkane, as well as preparation of alkene. Today we will start the physical and chemical properties of alkene. So what's about the physical properties? Physical properties of alkene. So physical properties of alkene is what? So the first one is like ethene, propene and the butene. Ethene, propene and butene. These three alkenes are gases in nature. These are gases. Next 14 member. Next 14 means what? Means pentene to next C18 alkene. Now these are the liquids. And why the higher than more than C18 carbon alkenes are solid in nature. Now the second one is the boiling point. Boiling point, if you remember, boiling point I've given you the concept. Boiling point is directly proportional to molecular mass. So as the molecular mass of the alkene will increase, the boiling point will also increase. Now second one, the boiling point is also directly proportional to surface area. As the surface area of alkene will increase, then boiling point will also increase. Now so next one we have the solubility part. Solubility is what? Solubility. So if you remember, I told you we discussed about this, that like dissolves like and the polar dissolves polar. So like dissolves like dissolves like means polar dissolves polar dissolves polar, and the non-polar dissolves non-polar, non-polar dissolves non-polar. No? So these alkenes are insoluble in water, because alkene is the non-polar where the water is polar. So alkene are insoluble in water, because water is polar and alkenes are non-polar, whereas alkenes are soluble in organic solvent, organic solvent is what? Like organic solvent we can say like ether, benzene, etc. Like ether, benzene. So these are what? Organic solvent. And all organic solvent is what? Is a non-polar in nature. So non-polar will dissolve non-polar. So alkene, which is the non-polar, it will soluble in non-polar solvent like ether and benzene. Now next one is about the density. So what's about the density? So density is what? Density again, density is also directly proportional to molecular mass. So as the molecular mass will increase, the density will also increase. Now, and one thing you should keep in mind, that is this is alkenes are lighter than water. Alkenes are lighter than water. So these are the concepts regarding the physical properties. Now let's move towards the chemical properties. So what's about the chemical properties? So chemical properties. So now have a look here. So when you just draw the structure of alkene, so alkene shows electrophilic addition reaction. Alkene shows electrophilic addition reaction. If you remember, what are the electrophiles? So electrophiles are those which have electron deficient. All electron deficient species are electrophiles. Those are the electron loving. So these undergoes electrophilic addition reaction because it have a double bond. So double bond will break it will form what? Addition reaction. So addition reaction, then it will form if x is x plus and y minus, like this, if then it will be form such type of the compound which have one will have, so suppose this is have hydrogen over here, so put other hydrogen over here, and what will happen over here? So x will get attached over here, y will get attached over here. So this is the addition reaction, nah? But it will not undergo substitution reaction, nah? Because it have one sigma bond and is broken, and a new sigma bond will formed, nah? So that's why. So let's move towards the mechanism part of electrophilic addition reaction of alkene, nah? So write down the mechanism first. Wait a second. Yeah, let's move towards the mechanism of electrophilic addition reaction. Mechanism of electrophilic addition reaction to alkene. So what is this? So have a look here. In step one, suppose we do the bromination, nah? So we just take the bromine just like this, and it will form what? Br plus and the B again Br minus, nah? So polarized bromine. This is known the polarized bromine molecule, nah? Bromine molecule. And so this is your alkene is what? CH2 double bond CH2. So this is your alkene. So when it will react with the Br plus and the Br minus, nah? So this is slide charges. So what will happen? So this bond will get break down, and it will form what? CH2. Simply it will form CH2 plus Br minus, and one Br will get attached over here, and this will develop a positive charge, nah? So this is the carbocation, nah? This is the carbocation of what? So bromoethyl carbocation. This is the bromoethyl carbocation. Now in step 2, what will happen? So step 2 is over here. Step 2. So now this Br minus plus CH2 plus and CH2Br. This is the bromoethyl carbocation. So it will form what? So it will get attached over here. So it is simply get attached over here, and it will form CH2Br over here. So it will form 1,2-dibromo ethane. 1,2-dibromo ethane. So this is the mechanism of electrophilic addition reaction to alkene. Now have a look here. I just like to give you the direct reaction. So the first one we have what? Addition to hydrogen. So when the alkene is react with the this is the in presence is reduced or hydrogenated with the catalytic or undergoes catalytic hydrogenation in presence of platinum, nickel, nah? So this is known as what? This is known as hydrogenation of alkene or reduction of alkene, we can say. So have a look here. I'm just giving the example directly. So this is the example. Like suppose we have the CH2 double bond CH2 hydrogenation in presence of Raney nickel. Raney nickel is what? Raney nickel is reactive nickel, we can say. Raney nickel. Or platinum you can use, anyone you can use over here. So this double bond will break and one hydrogen will get attached over here, one hydrogen will get attached over here. So it will give you CH3, huh? And this is what? Ethane. This is what? Ethane. Now in the similar way, if you take the other one butene or something, so like CH3 CH2 CH double bond CH2 plus H2 in presence of platinum or nickel. Na, if you take the nickel, na, suppose you take the nickel, na, then what will happen? Again, this bond will get break and it will form butane. Then CH3 CH2 CH2 CH3 4 carbon alkane, that's the butane will form. Now this is this addition reaction with Raney nickel at so there is some temperature over here, and temperature is 523 to 573 Kelvin. Na, if it happens so, then this is known as reducing agent. What we are using? So catalytic catalyst, or basically we say reducing agent. So what the reducing agent you take? So you take platinum, palladium, or you can say nickel, na, and temperature I told you. So the Raney nickel is what? Raney nickel is the active. Raney means active nickel, nickel, na. So if it this hydrogenation of alkene, it have a name reaction. This is known as Sabatier and Sanderens reaction, or the name is, it's a very important one, Sabatier. S-A-B, wait a second, S-A-B-A T-I-E-R, Sabatier and Sanderens, S-C-N-D-Sanderens, D-E-R-E-N, Sanderens reaction, na, or reduction. So this is the name reaction. You should keep in mind what the name of the name reaction is. Sabatier and Sanderens reaction. Got it? So this you should keep in mind. Now the next one we will just move to us. The next reaction is what? Next one is addition of halogen. If addition of halogen took place, halogen you can take like fluorine, chlorine, bromine, iodine. These are the halogens. Na, so if the halogenation takes place, na, in presence of some organic solvent like CCl4, the ether, na. So this is what? This is known as addition of halogen. Suppose with the bromine like CH2, like we just take the ethene first. I'll just give you the simplest example. Alkene, this is ethene plus bromine in presence of CCl4 as an organic solvent, then it form, this bond will get break and one bromine will get attached over here, one will get attached over here. So this will be CH2 and this is the Br. Now basically this is the 1,2-dibromo-1,2-dibromoethane. This is also known as vicinal dihalide because two consecutive carbon have two halogens. Now this is also known as test for unsaturated carbon, unsaturated hydrocarbon. So the bromine have what orange color, orange red color. What the color bromine have? Bromine have orange red color. But when it react with the alkene and forms dibromide, then the color is decolorized. Na? So it becomes colorless. So this is known as test for saturation in organic compound. This is what? Test for unsaturation in organic compound. If any organic compound have double or triple bond, when it react with the bromine in organic solvent, the color of bromine, what the color of the bromine is? Its color is red. Now the color is orange red. When the orange red color decolorizes, so it indicates the presence of double or triple bond over there. Now we'll just move next towards the Next one, what the next one is? Addition of halogen acid. Addition of halogen acid. Halogen acid. This is a very important one. Halogen acid is what? HX. HX, it may be HCl, HBr, HI, anything it may be over here. Now, but before before this, I would just like to give you some concept that is known as the Markovnikov rule and the anti-Markovnikov rule. Now, so what the Markovnikov rule and the anti-Markovnikov rule, I would just like to explain here first, then we'll just move ahead. But before that, if the addition to asymmetrical alkene took place, now and so what will the mechanism, and when the addition of unsymmetrical alkene is there, then what will happen? So have a look here. So first we'll discuss about like simply addition of halogen is, or simply we can say like this is alkene. We have any alkene you can take. Now it may be alkyl group or hydrogen over here. So when it H plus and the X minus will get attached, so one will get attached over here, one will get attached over here. So it is just like this, RR C and C RR, and here one will have the hydrogen and other will have the halogen. But here the question, if it is the such a symmetrical one, then it's okay. Now if it is unsymmetrical, then what? So if it is a symmetrical one, so there is some rule we have to follow. So what the rule is, first let's discuss about the rule, then we'll just move ahead. Have a look here. There is a rule, this is known the Markovnikov rule. Markovnikov's rule. So what's the Markovnikov's rule? So Markovnikov's rule states that the negative addendum, addendum means part, the negative addendum, that addendum means part. What the meaning of the negative addendum means? Suppose as HBr is there, so H plus Br minus, so Br minus is negative addendum. So the negative addendum, negative part will attach to that unsaturated carbon atom, which will have what? Less number of hydrogen atom, less number of hydrogen atom. So let's give one example, like CH3 CH double bond CH2. This is your alkene. Now here we put the HBr, H plus Br minus. Now what will happen? So according to the Markovnikov rule, this negative part will attach with the unsaturated hydrocarbon. This is the unsaturated hydrocarbon. So this is the unsaturated hydrocarbon. This is the unsaturated hydrocarbon. This is the unsaturated carbon, and this is the unsaturated. Two unsaturated carbon is over here. Now, but question is arises to which the Br minus will get attached. So those unsaturated will attach to that unsaturated carbon atom, which will have less number of hydrogen. So have a look at this. This is also unsaturated carbon. It have two hydrogen, and this is also the unsaturated carbon. With this have only one hydrogen, because this is this side is the carbon is attached to which the hydrogen is attached. So this is not considered. So it have only one hydrogen. So out of these have one less hydrogen. So Br minus will get attached over here. So Br minus will get attached over here. So the product will be CH3CH, and here it will be the Br, and this hydrogen will get attached over here. This hydrogen will get attached over here. So this bromine negative part will attach to this carbon, and this hydrogen will get attached to this carbon. Now, so now this carbon have what? Already it have two hydrogen. It have greater hydrogen. greater number of hydrogen. Now again the hydrogen get attached. So what? We for remembering purpose we should keep in mind that rich become richer, rich become richer, and the poor become poorer, poor become poorer. So this carbon have two hydrogen, na? This carbon have two hydrogen, so it will all gain one more hydrogen. So it is the rich become richer, na? And this have less hydrogen, so it will get attached negative part, so poor become poorer. So this is the concept regarding Marconi curve rule. Now what's about the anti-Marconi curve rule? So what is the anti-Marconi curve rule? Anti-Marconi curves rule. So what is the anti-Marconi curves rule is also known as anti-Marconi curve rule is also known as what? Peroxide effect. Peroxide effect, or we also say it Kharras effect. Kharras effect. Yeah. So this is the anti-Marconi curve rule. So what's about the anti-Marconi curve rule, and why it is known as a peroxide effect, and why it is known as Kharras effect? So peroxide effect is why it is known as the peroxide effect, because this is took place in presence of peroxide as a catalyst. So how will you say it? So in anti-Marconi curve rule, the negative addendum means negative part will attach to that unsaturated carbon atom, that unsaturated carbon atom which will have more number of hydrogen atom, more number of hydrogen atom in presence of peroxide. Now whatever the peroxide, like benzoyl peroxide. So benzoyl peroxide is what? Is the C6H5 CO whole twice O2. CO whole twice O2. So this is the benzoyl peroxide. So this is also known the peroxide effect. So let's take one example. So what the example is? To which example we will take? So we will take the example of again ethene, CH3CH double bond CH2. So which is the unsaturated carbon atom over here? So two unsaturated carbon atom, and which have the more number of hydrogen. More number of hydrogen is what? This have the more number of hydrogen. So negative addendum means Br minus will get attached to which one? Which it will get attached to this one. So it will attach to this one. So now in presence of peroxide means benzoyl peroxide, we can use benzoyl peroxide. So benzoyl peroxide we have, I told you about the benzoyl peroxide. So Br will attach to this one, so your product will be CH3, this hydrogen will get attached over here, CH2, and this is CHHBr. So this is the one bromopropane. This is one bromopropane. So how you can remember this? So to remember this, we have the concept rich become poor. Rich become poor, and the poor become rich. Poor become rich. So which is the rich over here? So it have two hydrogen, na? So now rich become poor. So rich become poor because this will have Br minus will get attached, and this is the poor. Poor will become rich because it have only one hydrogen, na. So it will one hydrogen more will get attached over here. So this is the anti-Markovnikov rule. This is what? This is anti-Markovnikov rule. Now next move towards the next one. Mechanism part is also very important for this one. So now have a look here. Wait a second. Now we can also write benzoyl peroxide can be written just like this: COO, increase one more oxygen and give twice over here, because benzoyl peroxide is just like this: C6H5, C double bond O, C double bond O, C6H5. So this is the benzoyl peroxide. So whenever the peroxide is there, that's the anti-Markovnikov rule. So that's it. Now, so make one more thing that in anti-Markovnikov rule, anti-Markovnikov's rule, only HBr is used. Why? So the thing is what this anti-Markovnikov rule completes in two steps, na? And in both the step, the halogen which is good, which is convenient to participate in the reaction, that is the bromine, na? Because have a look. I just like to give you differences between this. Okay, suppose here with the fluorine, suppose element is the fluorine over here. So fluorine or put the fluorine over here only. This is the fluorine, chlorine, bromine and iodine, na? And this they have the delta H1 and this is the delta H2, na? So in first case the it is minus 209, it have observed an exothermic reaction, but in second step it is a plus 159, so it is an endothermic reaction. With chlorine, in first enthalpy is minus 101 in first step, and the second is plus 27. This is the one is the exothermic, other is the endothermic. Iodine is what? Iodine is plus 12 in first step, means in first step is the endothermic, and second step is the 104, that's the exothermic. But that's only bromine, which in first step it is a minus 42 and in second step it is minus 37. In both the reactions it is the exothermic, na? So it shows the consistent performance. So since it shows the consistent performance, so it is what? It is used in the anti-Markovnikov rules. Now have a look here. We have to move some reactions. So what the reactions we have? So addition of hypohalous acid. Hypohalous acid is what? Addition of hypohalous acid. Hypohalous acid is, that is the HOX. So you can take HOCl, HOBr. So this is the hypohalous chloride, hypohalous bromide, hypohalous iodide, just like this. So it will take place, then what will happen? So in this reaction it is also will follow the Markovnikov's rule. Have a look here. If we take something like CH2 double bound CH2, so plus HOCl. Now HOCl is what? So Cl is negative, oxygen is more electronegative, minus, this is plus over here. So since it is symmetrical, so no there is no use of Markovnikov rule over here, so or anti-Markovnikov, since symmetrical one, so it will just like it will form a compound just like this. But if it's the unsymmetrical, like this is CH3 CH double bond over double bond CH2 plus HOCl. So what will happen? We will use the Markovnikov rule, and negative addendum will attach to that one which have the less number of hydrogen. So negative addendum is which one? This is the negative, this is the positive. So out of this, which have a less number of hydrogen, this is the less number of hydrogen. So we will use, when there is no peroxide is used in a chemical reaction, that we will use Markovnikov rule. So here we have not used any peroxide over here, since it is a Markovnikov rule. So OH will get attached over here, then CH3 CH OH, and this is the CH2 and Cl will get attached over here. So what the name? So 1 bromo propane 2 ol. This is what? 1 bromo propane 2 ol. And the second number 1 bromo. We will start since chloro. So 1 chloro. We put 1 chloro. Is what? 1 chloro and propane 2 ol. 2 ol. Now we start from this side counting, so it will just like this. In this case is what? We will start counting from which one? We will start counting from this side only. So it is the 2 chloro ethanol, ethane 1 ol or ethanol. So this is now the next one, next addition reaction we have. So which is the next addition reaction? So sulfuric acid. So addition of H2SO4. So what the reaction? Just I'm writing the reaction directly. CH2 double bond CH2. H2SO4 can be written as H plus OSO2 OH minus. This is the minus. So again, if you use there is no peroxide is there. So we will use Markovnikov rule. So again, in this case, this is the symmetrical, so there is no use. So we'll write CH3, CH2, OSO2 OH, and this is known as ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Now, if you use the like propene, like CH3, CH double bond CH2. So what will happen? So again, we'll write H plus OSO2 OH. Now this is the minus. So according to Markovnikov rule, negative part will attach to that carbon unsaturated carbon atom which have less number of hydrogen. So it have the less number of hydrogen. So negative part OSO2 OH will get attached over here, and it is the CH3. So what was the name of this compound? This is the isopropyl hydrogen sulfate. Isopropyl in between. So isopropyl hydrogen sulfate. So this is the isopropyl hydrogen sulfate. Now just move to the next reaction. So a lot of reaction we have to cover in alkene. So I'm a little bit fast. So now addition of water. So what's about the water? Water is H2O, and same Markovnikov rule we have to use over here. So suppose we just take CH3 CH double bond CH2. So again in water we have H plus OH minus. So H plus OH minus, negative part is this one, and this have less hydrogen, so it will attach over here. So CH3 CH OH, and this is CH3, and this is on the propane 2 ol. I think you understand the Markovnikov rule very easily. Now the next one, oxidation reaction. We are discussing about the oxidation reaction. So what's about the oxidation? Let's change this page. So oxidation reaction is what? Oxidation reaction. So what's about the oxidation reaction? So addition of oxygen. So there is different type of oxidation reaction of alkene. Now have a look here. First one, this is the complete oxidation. Complete oxidation. So complete oxidation of alkene will it will give? It will give you the carbon dioxide plus H2O. So it's plus heat plus light. Plus heat plus light. You should keep in mind. So what the suppose we just take the CH3, CH2 double bond CH2. So 2 carbon. So you oxidize with this oxygen. Complete oxidation is to give you CO2 plus H2O. Na? So 2H2O and 2 CO2. This is the balanced equation. So this is the simple one. Now the next one is oxidation with oxygen. Addition of oxygen is also the oxidation. So addition of oxygen. Addition of oxygen. Yeah. So like ethene, we have ethene. It is oxidized with oxygen directly in presence of silver. Now silver at there is a condition 575 Kelvin temperature you have to use. So what will happen? So we'll use one atom of oxygen. So 1/2 we put over here, and what? So it will form CH2 single bond CH2. This bond it will break, and oxygen will get attached to this one. And this is known the epoxy ethane. Is what? Epoxy ethane. This is your epoxy ethane. Nah? So now if it's like if you take the propene, so what will happen? So this is the like this CH double bond CH2. We have to take only half O2, and if you take the half O2, then what will be the product? It will be, so this bond will break and it will form CH3 CH2, and this oxygen will attach from here at 1 2 position. Nah? So at 1 and 2 position it is attached. So simply what you say, 1 2 epoxy propane, 1 2 epoxy, 1 2 epoxy, and total is 3 carbon, then propane. Okay. Now let's move towards the next reaction. So next reaction is what? Next reaction is also the oxidation, but in presence of some oxidizing agent. Yeah. So first one, oxidation with cold and dilute is very, condition is very important. Cold and dilute or cold with cold dilute neutral or alkali or alkaline KMnO4. So this is the KMnO4. So this is the condition. This is very important. Cold and dilute neutral KMnO4. Nah? So what will happen? So when you take this, then this reaction is called hydroxylation. Nah? So how the reaction will proceed and what will be formed? So in this process, 2 hydroxyl group. 2 hydroxyl means OH group. Now are added. Where it is added? Added across the double bond. Across the double bond. Now, so that's why it is known as a hydroxylation. So how the reaction will proceed? Have a look here. Basically, KMnO4 is what? KMnO4 is oxidizing agent, that it will give you the nascent oxygen. So 2 KMnO4 plus in a neutral or alkaline medium, it will give you 2 KOH plus 2 MnO2 plus 3O. This is known as the nascent oxygen. Nascent means reactive. Nascent oxygen, those oxygen which is formed just after the reaction, and this is very reactive. So what will happen? How it will react with the alkene? Suppose we have taken a CH2 double bond CH2, and in presence of H2O plus nascent oxygen, which we got from the KMnO4, then it will form at a 298 Kelvin or to 303 Kelvin temperature in between. Then it will form CH2OH and CH2OH. How? Have a look at this. Is what total is what? How? CH2O plus O. Then we have 2OH. OH. We can write 2OH. So this bond will get break, and one OH will get attached over here. OH will get it over here. So this is known as ethylene glycol. It is what? Ethane 1,2-diol or ethylene glycol. If you remember, I told you ethylene glycol is what? This is a dihydric alcohol, and it is also used in cough syrup. Glycodine cough syrup, I told you. So this is like this one. Now next one is what? So this is the first condition with the KMnO4 with the dilute, neutral or alkaline, and the second one we have. Second reaction is what? Second reaction is just like this. Now oxidation with hot KMnO4. Acha, wait a second. Now the color of in this reaction is some important information I just like to give you. The color of basically KMnO4 is pink. This is the pink color, pink in color. So when it reacts with the alkene, it discharges and a brown precipitate of manganese dioxide is formed. When it reacts, then this is the manganese dioxide, and it forms brown precipitate, brown PPT. So it forms brown precipitate. So therefore this is also used for the test for unsaturated saturation, and this is known as Bayer's test. This is what? Bayer's test. You should remember. BAYER, Bayer's test. So what the Bayer's test? This is the test for unsaturation. Test for unsaturation. How? So when it react with the KMnO4, KMnO4 have the pink color. So when it react with the alkene like ethene, so its color changes into brown precipitate due to the formation of manganese dioxide. So this is a test. Its name under Bayer's test. Or this reagent 1% alkaline KMnO4 is 1% alkaline KMnO4 which is diluted now. So dilute KMnO4 is known as Bayer's reagent. So 1% or diluted alkaline KMnO4, it is known as Bayer's reagent. So this is a very important information. So you should keep in mind. Now we just move to the next one. So next one is what? Next one is oxidation with hot KMnO4 solution. Now the condition is changed. That was the cold and dilute KMnO4. This is the oxidation with hot KMnO4. So that forms hydroxylation, and in this case, when alkene is treated with the hot KMnO4 solution, so due to breaking of double bond, it forms carboxylic acid, ketone, and carbon dioxide. So forms with hot KMnO4 alkene with hot KMnO4. It forms carboxylic acid, ketones or carbon dioxide. It depends what the alkene you have taken. So the terminal alkene, terminal is what? Wait a second, like CH2 double bond CH2. So this is the terminal carbon. So terminal carbon is just like this. So it will always form with the oxidation of KMnO4 with the in presence KMnO4, hot KMnO4. It will give you what? Carbon dioxide and water. First it will form one carbon. This bond will break, and 1 carbon carboxylic acid, 1 carbon carboxylic acid, and 1 carbon carboxylic acid is formic acid, and formic acid is not stable, so it will get break down into CO2 plus H2O. So wherever the terminal carbon CH2, which is attached to the double bond, so it will give you CO2 plus H2O. Now have a look. I'll just like to give some more examples so your concept will be clear. Have a look here. So CH3, CH, double bond CH2. So with a nascent oxygen we have taken. So what will happen? So breaking will take place from here. So this is first with a 1 carbon carboxylic acid. So it will give you CO2 plus H2O. Direct just write on CO2 H2O for 1 carbon. Because it will form formic acid, further it will undergo oxidation, it will give you CO2 H2O. And this is the 2 carbon carboxylic acid, and 2 carbon carboxylic acid is CH3, C double bond OOH, and this is known as the ethanoic acid. What is it known as? Ethanoic acid. And ethanoic acid is also known as the acetic acid. Where we use the acetic acid, then it is used in vinegar, which we use in a food items. Okay, now if you take iso 2-methyl propene, like compound like CH3, CH3, double bond CH2, it undergoes oxidation, nascent oxygen with a hot K1O4. Hot K1O4 is very important. So what will happen over here? So this bond will get break. Once this bond will get break, then 1 carbon carboxylic acid, that's a formic acid, so it will form CO2 plus H2O. Now for this part, it is now this is branched alkene like this, so it will not form the carboxylic acid. Here it will form ketone. So ketone is what? CH3, C double bond O, CH3. So this is the 3 carbon, then propanone or acetone. What do you write? Propanone, or this is commercially known as acetone. So you should keep in mind. Now let's so non-terminal this is the terminal. This is what? This is known as terminal alkene. And this is a non-terminal alkene. So have a look here. I just like to give some more example, so your concept will be more probably it will clear. CH3, double bond C, CH3. So in this case, what will happen? It will undergo oxidation, so in presence of KMNO4. So it will get break from here, and it will form 2 ketone. So is 2 ketone is what? Is a CH3, and the C double bond O over here, and again this side is the same. So it's the CH3, double bond C double bond. So this is the acetone. This is 2 molecules of acetone they can form. Now look some more example. So solving the question is very important in organic chemistry. Once your concept is okay, then your concept is good. But practicing the concept is most important part. Otherwise, what you know the concept is okay, but if you have not practiced the concept, you have not practiced the question, then it will be useless. So you have also to solve the question. So again, in this case, so this is where it is the non-branched. So non-branched, this is not branched. This is also not branched. So most probably they will form the carboxylic acid. So 1 to 3 carbon carboxylic acid, CH3, CH2, C double bond OOH, and this is what? This is 2 carbon, then CH3, C double bond OH. So it forms propanoic acid, propanoic acid, and it will form ethanoic acid. Simple one. If the branching is there so most probably it will form ketone. If the branching is there, then it will form ketone. But it is non-branched, so most probably it will give you carboxylic acid. One more, like CH3, CH2, CH double bond, CH3. So again, with the whatever the oxygen, you have to take the nascent oxygen, whatever you required. So with a KMnO4, hot KMnO4. You should keep in mind the reaction is all about hot KMnO4. So this is also the non-branch. So it will not form the ketone. So it will form carboxylic acid, the 2 carbon carboxylic acid and 3 carbon carboxylic acid this side. Na? So same. I'm giving the same example. So this is the same one. Now if I change. I have to change a little bit. I just reduce 1 carbon over here. So CH3CH. CH3CH. So both the side is the same carbon. CH3. Wait a second. CH3CH. CH3CH. So it will give you 2 molecule of CH3 C double bond O OH. Simple one. So this is all about. So if it is straight chain, no branching, then all alkene undergoes oxidation with a hot KMnO4 and it will give you carboxylic acid. If it is a non-terminal, if it is a terminal carbon atom like CH2, then it will give you CO2H2. Now the most important reaction we are going to discuss. So this is known as oxidation with ozone. Oxidation with ozone. And oxidation with ozone is what? This is known as ozonolysis. This is known as ozonolysis. Nah. So ozone, what are the condition for the ozonolysis? So the ozonolysis can take place. All alkene is required. So obviously alkene will be there. So and ozone will be required, obviously. And we just take some solvent. Nah. Like inert solvent, we have to take inert solvent. So what type of the inert solvent you can take? Like CH2Cl2, methylene dichloride, chloroform you can take, chloroform, carbon tetrachloride is you can take. So these are the inert organic solvent you have to take. The one more thing, the temperature. So temperature we have to take what the temperature? So temperature 196 to 200 Kelvin temperature. And one more thing you should keep in mind, then zinc and water you have to take. Nah? So how the reaction will get proceed? Let's move. This is very, very important one. So you should keep in mind. So it will also use in conversion part, and it is also is a direct question they can ask you. Now have a look here. Like CH2 double bond CH2. We just take the example. And if it undergoes ozonolysis in presence of, so ozonolysis will take in presence of CH2, Cl2, what are the temperatures, just write down here. So this bond will get break. Both bond will get break, and in place of that, ozone will get attached just like this. CH2, CH2, and this ozone will get attached like this. O. Now what will happen with now we will use a zinc over here. So zinc will there is a breaking will take place just like this. Breaking, how it will break? So it will break just like this, like this. Okay, and this zinc will react with the O and it will form ZNO. It will form as a byproduct. So left the byproduct. Now whatever the carbon it have, it may be the number of carbon, any number of carbon it may be here. So what may be the number of carbon over here? It will attach with this oxygen with double bond. Now have a look here. This carbon is attached with this one with a double bond and 2 hydrogen. So we put 1 hydrogen this side, 1 hydrogen this side. In this side is over. Now we just think about this other side. Other side is which one? This one. This side. So this carbon. Put the carbon over here, and this oxygen will get attached to this one with a double bond. Put the double bond over here. Both sides is a hydrogen. Put the hydrogen over here. So when ethene undergoes ozonolysis, then it will form what? 2 molecule of formaldehyde or methanol. This is what? This is your methanol. This is what? Methanol or formaldehyde. 2 molecule of formaldehyde it will form. I hope you understand. I just like to give you some more question, so your concept will be clear regarding this one. So suppose we take the ethene, CH3, CH, double bond, CH2. Now in this case, what will happen? We take the ozone. Now simply this bond will lost, and what will happen? Now this side is the CH3, CH, this side is CH, and this ozone, this ozone will get attached with this one, just like this. Ozone is attached. Now what will happen? There will be breaking in presence of zinc. So how the breaking will take place? So it will take place from here, this side and this side. Zn is out, Zn is out as a byproduct. Now this side, just look about this side. There is 2 carbon, and this carbon is attached to the oxygen. So put this carbon with a double bond. This carbon double bond. One side hydrogen, put the hydrogen, and this side is the CH3, put the CH3. So this is the one side is over. Now this side, this carbon have double bond, this carbon have double bond. Both side is the hydrogen, both side is the hydrogen. So it forms 2 molecule, and this time 2 molecule is what? This is a 2 carbon is ethanol, and this is 1 carbon is methanol or formaldehyde. I hope you understand. Now just move to the next one. Next one is what? Take the example of like CH3, CH3 double bond CH3, just like this. So what will happen now in this case? Again, this concept is very easy. Lost, this double bond is lost. And this side, what is this side? CH3, CH3. And what is this side? This side is CH3, H. And what we will do? We will add the ozone. Ozone, O. This ozone is attached from here. And what? Next one is what? Cleavage. In presence of what? Zinc. In presence of zinc, there will be cleavage. Cleavage from this side, very nice. Right side, very nice. So ZNO is out. ZNO is out. What? This carbon is attached with a double bond. So this carbon is attached with a double bond. Both side is the CH3, and both side is the CH3. Now this carbon again. Now this carbon is attached with a double bond. Put this carbon, double bond. Left side is hydrogen, right side is the CH3. Put the right side is the CH3, just like this. This is the what? This is the ketone. Now they form the ketone, not the aldehyde. This is the ketone. So they can form the ketone or the aldehyde, whatever the. It depends upon the what type of the alkene we have taken. So in this case, this is a propanone. So propane 2-on, or simply it is known as acetone, which we use in as a commercial name. So now this 2 carbon is ethanol, and what the 2 carbon is also known as acetaldehyde. So this is very important. So you should keep in mind. Now next, we just take one more example. I hope you are getting the thing very clearly. So we have done which one? We have. How many examples we have taken? This one. Yeah, this one we have taken. One more. I'm taking one more. Like CH3 is very easy. Nah? So only you have to understand how the cleavage is taking place. Otherwise, it is very easy one, isn't it? Now is the ozone. As the ozone is what? Again, this double bond will lost. So if it is lost, then what left behind? So it's the CH3, and double C, and this side again CH3, and how it will attach with the ozone, like this. This is the attachment of the ozone, and in presence of zinc, how the cleavage will take place. So we can cleave it just like this, from this side, simple one. So ZN is out, and what the next one? So is a CH3. This carbon is attached with a double bond, and both sides is a CH3. So put the CH3 both side of this carbon, and double bond over here. So this is the propanone, and again this side is again the same. Same is what? CH3, C have the double bond, and then CH3. So this is the acetone. So 2 molecules of acetone. Both are the acetone. Nah? Both are the propanone or acetone. So this is the ozone. This is very important one. Now sometimes the question is reversed. Now how the question is reversed? Sometimes we just take some more example. Now cyclopropene is just like this. This is the cyclopropene. This is what? Cyclopropene. propene. So what will happen if it undergoes ozonolysis? So what? So is a double bond. What I told you. Acha, first you just write the structure of cyclo. So CH, CH2. This is CH. Why I have written CH? Because carbon is tetravalent. So 1, 2, 3, 4. 1, 2, 3, 4. And this is 1, 2, 3, 4. Because it's a double bond, so only CH we have taken. Now, what I told you, double bond will get vanished. So double bond will get vanished from here. So what will be now how the reaction will proceed? I can take this one in opposite way. Like we can put just like this. If the double bond is break, then it will be CH, CH2, CH2, and this is CH. And if the ozonolysis will take place, then how? So ozonolysis will take place in opposite way. Wait a second. How we can show you very easily? I want to show you some easy thing. One thing is clear: if the double bond will get attached to this one, but if I move just like this, like CH, CH2, and ozonolysis. If we put the ozonolysis like no, I'm getting little bit so it will break from here. It will break. Oh yeah, let's see that. I just move it. Good. Just do just like this. CH2, CH, and put ozone over here. O. Okay. Now zinc is over here. So what will happen? So it will break out from here. See, that's a 3-dimensional. It will happen now. So it will not break. That's backward. So it will break out from here. Keton is out. Plus this carbon is double bond H, and this is the CH2 at its own place, and this carbon is a double bond over here. So this is the product. So this is what known as a 1, 2, 3. Now you got it how it happened. So this is what it will get out from here, and C double bond will get attached. To this carbon. That's it. This is not the breaking from here. This is breaking from here only. Otherwise, you will cut the above carbon. So just like this. So this is, or simply you should keep in mind where it is. You are breaking the double bond. You put the double bond over here. One double bond over here. Double bond over here. Double bond here. That's it. So you can do by these two. So cyclopropane will give you what? Propane 1, 2 dial. This is very important one, so you should keep in mind. Now sometimes the question is asked reverse, because they are saying the question will they will say you got the product of ozonolysis is ethanol and ethanol and suppose acetone means propane 2 on. Now find out alkene. So what alkene you have taken? This is the reverse question. Now they are not asking you to do the ozonolysis of alkene. They are asking, you got the product and you have to find out the alkene. So just do simply, it can be solved very. Ethanol is what? We can write CH3 2 carbon aldehyde ethanol. na, and propane non means 2. This is the CH3 and put CH3 or double bond. What you have to do? You have to put the double bond just face to face. Na, so this side the propane 2 on. This is the CH3 C double bond OH ethanol. So this is the ethanol. This is propane 2 on. What you have to do? Just remove this oxygen and add this carbon over here. That's it. So this is the CH3 over here. CH. Remove this oxygen and in place of that put the double bond, and this is the CH3 over here. CH3 over here. Simple. So this is your alkene you got. Nah. So what the alkene? So this alkene undergoes ozonolysis to give the ethanol. So what the name of the alkene it will have? So is the 1, 2, 3, 4. 4 is what? But 2 in and 2 position is 2 methyl. So 2 methyl but 2 in. Na? Simple one. Now I'm just giving one more question. I hope you will understand that one too. You have to find out the alkene. Question is the same. You have to find the alkene, and they have given you this time. They have given you the product of ozonolysis. What they have given product of ozonolysis? Ozonolysis this time is ethanol. That is the CH3 C double bond OH. Again, second was the glyoxal. Glyoxal is what? Glyoxal is C double bond OH. C double bond OH. This is not the glyoxal. One is the ethanol. Other is the glyoxal. This is the glyoxal. 1,2-diol is glyoxal. And again they have taken propanol. Propanol is what? CH3 C double bond O CH3. This is what? Propanol. This is your propanol. So they are asking the alkene. What you have to do? This is a simple way. What the simple way is? Remove this oxygen from here, add all the product. So it will be CH3CH. From double bond it will be attached. So double bond CH, and from double bond just remove this oxygen and add the carbon over here. So this is the CH3. So you got the product. So whatever the product you got, that will be your answer. So your answer is 1, 2, 3, 4, 5, 6. 6 is what? Hex 2, 4 hex 2, 4 diene, and at the third position. Acha, you have to start from this side because alkyl group is also this side now. So you will start from this side. So now is how many number of carbon from here? So you will start from this 1, 2, 3, 4, 5, 6. So 2, 4. This is the 2, 4 diene, 2, 4 diene, and the second position 2 methyl. So when you do the ozonolysis of 2 methyl hex 2, 4 diene, then you will get 1 molecule of ethanol, 1 molecule of glyoxal, 1 molecule of propanol. I hope you understand. If you don't understand, then see this video again and again. You will understand it very easily. Isn't it? So now the product of ozonolysis they have given. Product of ozonolysis. What is the product? They have given 1 molecule of ethanol, CH3 C double bond OH, and 1 molecule of CO2. 1 molecule of CO2 they have given, and 1 molecule of anything you can. What do you want to say? Propanol or acetone. Just think about the acetone. So they have given 1 molecule of this one, 1 molecule of this one, 1 molecule of this one, 1 molecule. Nah? So what is the alkene? Nah? So what you have to do? You have to use your intelligence. So put the CH3 C double. What I told you, put the C double bond O face to face. CO2 have, you can write the CO2 just like this, C double bond O double bond. Simple one na. And acetone this side. Acetone this side again. CH3 C double bond O, and this is a CH3. And what you have to do? You have to remove this oxygen and add from there. This one. So this is the CH3 CH double bond C. Oxygen is out. C, and from here is oxygen is out. Double bond C. CH3 and CH3. So what the name? 1, 2, 3, 4, 5. 5 is what? Pent. 1, 2. This side you can start. 1, 2, 3, 4, 5. Then a pent. 2, 3 diene. 2, 3 diene. And at second position methyl. So 2 methyl, 2 methyl, 2 methyl, pent 2, 3 diene. I hope you understand. So such type of the question will ask from the ozonolysis, and this is a very, very important one. Nah. So you should keep in mind. Now I just like to give you one more question. Then there is one polymerization is there. Then this will finish. So ozonolysis, if you do the ozonolysis CH3 CH double bond C double bond CH2. So what will happen over here? Ozonolysis, then ozone you have to use over here. So what you have to do, what I told you, just remove this double bond from two side. This time it is two side. So CH3 C and this is the CH2. Now we have to take two ozone. So ozonolysis will take from this side and ozonolysis will take from this side. Nah. So what will happen? Just remove as I did earlier. So from here, nah, and from here, this side, or from here and from here. Very nice, simply. So zinc. So two, you have to take two zinc. So ZnO2 will out. So 2 molecule of ZnO will out, isn't it? So what will form? So this side CH3. Now this carbon is double bond OH. 1 molecule is, you got it. Second is what? This is C double bond O, C double bond O, means carbon dioxide you got. And this one is what? This is the CH2. So C double bond O and both side hydrogen. One this hydrogen, simply got. I hope you understand. If you didn't, then just see the video again and again. You will get the idea how it happened. Now have a look here. Polymerization. Polymerization is what? Polymerization. Polymerization is what? When the monomers get attached, when so many monomers get attached, it forms polymers. Nah. So many monomers get attached, it form one. So monomers, it will form a bigger molecule, that is the polymers. Nah. So when many monomers will get attached, condensed, means when you have a large number of, we can say, when the large number of polymerization is what? Large number of molecules get combined to form a bigger molecule. Get combined to form a bigger molecule. It is known as the polymerization. So we just move towards the someone polymerization of ethene. So you know the polythene we use in day-to-day life. So this is what? This is the polymerization. So polymerization of ethene. So what the polymerization of ethene? So we take the N molecule of CH2 double bond CH2 in presence of oxygen. Traces of oxygen at a particular high temperature and the high pressure. You just don't remember that. CH2 and it will form one bigger molecule. This is not a polythene. So in the similar way we can so many we have like polyprene. So N molecule of propene will combine in presence of peroxide, then it will go polyprene. Polyprene is what? CH2, CH, CH3 and the CH and N number of molecule. This is the polyprene. So here is the term Ziegler-Natta catalyst. Now there is no use of that, so you don't think about too much because in polyprene we use a Ziegler-Natta. So this is the silicate group. So this is the Ziegler-Natta catalyst. regular not a catalyst we use. So sodium potassium silicate, aluminum silicate. Aluminum silicate is known as Ziegler Natta catalyst. So there is no use of that now. When we will discuss about that later on. So there is some more PVC, polyvinyl chloride, PVC, polyvinyl chloride, polyvinyl chloride. So polyvinyl chloride is used in plastics. So polyvinyl, how you just prepare the polyvinyl chloride. So polyvinyl chloride, we take the CH2 double bond CHCl and N molecule of this one. So it will chloroethene is what? It is the chloroethene, and when a chloroethene undergoes polymerization, then it will give you CH2CH Cl over here, and this is what? This is your N molecules. So it will go PVC, polyvinyl chloride. So in the similar way, we have the PAN. PAN is what? PAN, polyacrylonitrile. So polyacryl, this is not PAN, is also formed from acrylonitrile, CH2 double bond CHCN. This is known as N molecule. This is known as acrylonitrile. Acrylonitrile. So acrylonitrile is what? That is the vinyl cyanide. Vinyl cyanide. So when the vinyl cyanide undergoes polymerization, then it forms PAN. PAN is what? PAN is what I told you. PAN is polyacrylonitrile. So they can ask you what the polyacrylonitrile, the monomer of the polyacrylonitrile. That is the vinyl cyanide is the monomer of polyacrylonitrile. Polyacrylonitrile. This is the PAN. PAN. So these are the someone they can ask you polytetrafluoroethene, Teflon. Teflon is what? Teflon is what? Teflon is known as polytetrafluoroethene. So how it is formed? So it is formed with the CF2 double bond CF2, and this is known as what? Tetrafluoroethene. So N molecule of tetrafluoroethene. Under polymerization, it will give you CF2 and N molecule of Teflon or polytetrafluoroethene. So these are the chemical properties of alkene. What's about the uses? So let's study some uses of this one. So uses, it is used as the PVC, which is used in Teflon and Orlon, means polythene. So polythene is also here, polythene. Polythene. So this is used as a what? In the formation of plastic bottles, syringe, and it is also used as antifreeze. Antifreeze is what? Antifreeze is nothing with alcohol with ethylene. Alcohol plus ethylene. What happens in a winter season when the temperature is very low? Then in our car or in our cars, we use antifreeze. So this is the alcohol plus ethylene is there. So now it is also used in artificial ripening of green food. So artificial ripening of fruits, it is used. So it is also used in the mustard gas. Mustard gas is what? Mustard gas is what used in World War First. So this is a war gas. This is known as the war gas, which is World War First. And World War First, when it took place in 1914 to 1918. So how it is formed? So it can be prepared by ethylene and the sulfur monochloride. Then it will form beta dash dichloro diethyl sulfide. So this is the mustard gas. So it is not so important, but still, if you want to remember, keep in mind, then you can. Now I'm just making a flow chart for you, so that will be very easy. That will be good for remembrance purpose. Mechanism of Marconi or anti-Marconi we will just discuss in a short video later on. But now let's study. I'm just giving you a flow chart. Flow chart of properties of alkene. So this is your alkene, and both sides have to make. I think it will number of reaction will be much bigger one. Okay. So first let's move this side. This side is what? First, when alkene is treated with hydrogen in presence of nickel, this is now the Sabatier sentence. Sabatier. And Sanderens reduction. So it will give you what? Alkane. Simply I am writing alkane. And next one, it in the bromination in presence of CCl4 the chloroform, anything you can take. So it will form what? It will form vicinal dihalide, or like this. I'm just writing this one. So if the one double bond break, so two halogen will get attached. So basically it is a vicinal dihalide. Again halogen acid HX. So you know how it will form. So it will form just like this. Like this. One will get attached halogen, one is hydrogen, and here we use Marconi of anti-Marconi, Marconi corps as well as anti-Marconi corps in presence of peroxide. So you should keep in mind how when it is when the reaction is going to be take place, either in presence of peroxide or in presence of what? In absence of peroxide. Now again in the presence of HOX, and it will also form what? Basically it forms this is another it will form halohydrines. Halohydrines means what? Like this is the halohydrines, this is the chlorine, OH will get attached, one OH over here, or one, wait a second, one OH is over here, one chlorine. So this is the halohydrines. This is the halohydrines. Now again this is with the addition of H2SO4. So what will give you? This is 4. This will give you RCH2 OSO2OH. This is form alkyl hydrogen sulfate. This is alkyl hydrogen sulfate. So you should keep in mind alkyl hydrogen sulfate. Now these are the what? These are the reaction with different hydrogen and halogen halide and the H2SO4. Now the oxidation. Oxidation is what? Oxidation is complete oxidation. Let's start from this side. It will be good. So complete oxidation, that is known as what? This is known as the combustion. So it will give you CO2H2O plus energy. And then with oxygen with silver, then it form epoxide, or epoxy ethane, epoxy. So it will give you epoxy. This is your epoxy. This is the epoxy ethane. 1, 2 epoxy ethane, epoxy ethane you can say. Now with the cold and dilute KMnO4 oxidizing agent. So what it will give you is it will give you glycol or the diol. Basically it will give you diol. So CH2OH, CH2OH. So it will give you diol. Now what's about the next one with the hot KMNO4? So with the hot KMNO4, it will give you a different product. So either it can give you the carboxylic acid or ketone or CO2 plus H2O. So it depends. So how I have explained everything, how the cleavage will take place. Now I hope you understand. You are getting the thing. It will give you carboxylic acid, ketone, carbon dioxide plus H2O, and it depends upon the what alkene you have taken. Now the next one is the ozonolysis. Ozonolysis, as you know, ozonolysis will give you either what, aldehyde or ketone. So it will give you either aldehyde, whatever the aldehyde, or it can give you the ketone. So this is the thing you should keep in mind. I explained everything about the ozonolysis, so I think you should keep in mind. Okay, now if the diene is there, ozonolysis take place in presence of zinc, so you should keep in mind. If the dienes is there, so it will form, it can form C glyoxal or the CO2, it depends. Now the last one is the polymerization. I am writing the polymerization over here. So polymerization is what? Polymerization. So polymerization. So polymerization can give you polythene. Polythene like CH2 double bond CH2. And so it can give you polythene, or it can give you what? It can give you like PVC. That is polyvinyl chloride. And it can also give you what, pan polyacrylonitrile. For that you have to take acrylonitrile. And again it is what, Teflon is also there. So Teflon. So all other polymerization product, polymerization of alkene derivatives. So mostly these equations are very important one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these are the polymerizers. So 10 chemical properties of alkenes, and we also discuss about the uses. In next video we'll discuss about the alkynes. Till then, take care and goodbye.